In the first part of this question, we're asked to calculate the acceleration of the car at time equals 6. So that is going to be here. And actually, this is during a period of constant acceleration because the velocity is decreasing in a linear fashion. And so actually, it's just a gradient of this line, and we can look at the gradient of the whole line, or part of it, but I'm going to go between here and here. So I can see I'm going along 3 seconds and I'm going down by 4 seconds, so minus 4. And therefore A is going to equal minus 4 over 3, which we could write as, to three significant figures, it's going to be minus 1.3 recurring, in fact, which will round to minus 1.33 meters per second to the minus 2. You could do this question by taking the 2 points and doing y2 minus y1 over x2 minus x1, but because we've got the graph, I just think it's easier to do it like this. In part B, Jasmine says the distance traveled by the car during the first 20 seconds is more than 5 times its displacement from A after the first 20 seconds. We need to give evidence to support this. So that's going to involve calculating distances or displacements, and it's going to be, or this is that I can calculate this red area here. Now that is just the area of a trapezium, or you could split it into a rectangle and a triangle, but best to learn the area of a trapezium. It's half times the 2 parallel sides added together. So it's going to be 5 plus 8, and then times by the height, so 4. That's going to be 2 times 13, or 26. And then we've got this green area, which is below the axis. So for displacement, it will become negative. For distance, it will remain positive. That's the crucial thing in this question, actually. So here it's actually a triangle. It's going to be a half base times height. Well, I'm going from 8 to 20, so it's actually going to be 12. And then I'm going to times that by minus 3, or just 3. That's going to be 6 times 3, 18. So my distance, I add them together. It's always positive distance. 26 plus 18, which is going to be 44 meters. Whilst displacement, I've got a positive displacement, but then I've got a negative displacement. So that's going to give me 8. Now, we're interested in how much bigger this one is than that one. So the way I did it is I just divided them. 44 divided by 8 is actually equal to 5.5, and this is greater than 5. The distance is more than 5 times the displacement. You could alternatively do it by getting the displacement and then timesing that by 5 and getting 40, and then showing that 44 is greater than 40. That's an alternative way of doing it, but both are fine. I do advise a little conclusion at the end because it says give evidence. So I've kind of given my evidence and then a supporting conclusion.